welcome to Apocalypse Now, the podcast where we dive into some of the most devastating environmental disasters and explore how we can prevent them from happening again. So today I'm looking at solutions that can prevent killer landslides from mining waste from ever happening. I'm Holly Stower. I'm an environmental researcher and advisor who's worked with big name companies to develop sustainable solutions and solve their environmental challenges. So we've spent a couple of weeks researching this to present you with the best solutions to mining disasters. Because environmental problems do have solutions. It's not an unsolvable puzzle. They exist and we either don't give them enough credit or don't give them enough support. So today is the second episode where I'm talking about the Aberfan disaster, which occurred in Wales in 1966. It was an entirely preventable but deadly landslide of mining waste from a coal mine waste tip, which killed 116 children and 28 adults as it engulfed the town's primary school and surrounding houses. So if you haven't listened to the first episode, do go back and listen where I outline what happened, why it happened. And in this episode, I'll discuss what happened next to prevent further disaster, where this disaster risk still looms, and what solutions exist to prevent these tragedies from ever happening again. So let's get into it. One of the most significant developments after the Aberfan disaster, and a requirement following the 78-day tribunal, was the very first legislation to govern mine and quarry waste tips and spoil heaps. The development of legislation also activated research into the factors that could actually cause the instability of these tips in the first place. This led to the Mines and Quarries Tips Act of 1969 and another one, 1971. This gave details on construction and inspection and some of the most significant requirements of the regulation, including defining what a mining waste tip actually is. It outlines stability requirements, so ensuring that these tips are properly designed, sited, constructed, and maintained, none of which happened at Aberfan. It set about what would a management plan look like. So these now needed to be completed, including geological assessments, plans for drainage of the tips, and regular evaluations of their stability. It required inspections and supervision. It's now required with powers given to the local authorities to enforce these inspections. It also founded a new division, the HM Inspectorate of Mines, and they were given the authority to supervise safety and standards. The Act also introduced liability penalties. If you remember in the last episode, no one was prosecuted for this disaster. So now, if corporations didn't follow the Act, it included criminal liability. So people could go to jail if they didn't follow the rules. And finally, authorities could also take emergency action if the tip posed an immediate danger. So back to our old pals, the National Coal Board. Whilst the National Coal Board utterly failed the families of Aberfan, undercompensated them following the disaster, they actually did put money and energy into preventing further disasters. So the National Coal Board and the Welsh Development Agency invested over 50 million. So that should be around £750 million or $905 million in today's money. They put this into investigating existing tips, as well as improving their stability. So the most significant outcome was that future tips were properly planned, they were sited and designed to ensure stability. As a result, there have only been a handful of minor tip failures and 0 known fatalities as a result of tip failure in the UK since the 60s. So this legislation has stood the test of time with no amendments and no exemptions until both documents were eventually replaced in 2014 with the new Mines Regulation 2014. However, many of these tips are still standing in the UK today, and 40% of those are in Wales. And in 2020, concerns over the threat from old coal tips resurfaced. there was a huge storm that caused a 60,000-ton landslide at a disused site in Wales, Rhondda Kenyon Taff in Wales. Thankfully, no one was injured, but this led to the establishment of a national database for disused tips in Wales. The analysis identified 2,566 disused tips, with 350 highlighted as higher risk. So this categorization indicates sort of continued commitment to monitoring from the government, and the government also allocated about £44 million to cover the maintenance of these old tips and prevent further disasters. So another key change in regulation was the founding of the very first Health and Safety at Work Act in 1974. This ended up being a act that was copied around the world. But at this time, there really wasn't health and safety written into law. Aberfan was really a catalyst for this, as well as there was an awful factory fire in 1968. This was the Stern Furniture factory fire in Glasgow. What happened was the owners closed all the fire doors. They locked the fire doors to prevent stealing. And as a fire broke out in a furniture store, lots of flammable things there, 22 people died. So this and Aberfan was a real catalyst to get this start going. So how did it start? Bringing back our old foe, Lord Robbins. He was actually appointed to chairman to develop the UK Health and Safety at Work Act. The same Lord Robbins who lied about the National Coal Board's knowledge of problems and the underlying spring at Tip 7 Aberfan, delayed the tribunal, drafted his flimsy resignation letter and rejection from the government, tried to undercut survivors from families, and then tried to blame them for the disaster. He wasn't prosecuted. He didn't even lose his job. He didn't even resign. But he was elected as chair of safety, which is a huge slap in the face for the community at Aberfan. However, seemingly he learned a lot of lessons and from the 60s and created somewhat of a redeeming character arc for Lord Robbins. And the Health and Safety at Work Act has pretty much been a good success. So firstly, the Act simplified a system. So with one act in authority, so HSE, anyone in the UK sees posters at work will have HSE still on them. So this one authority replaced several inspectors, statutes, and regulations. Secondly, was a shift to move to a more self-regulating and greater use of voluntary standards, enabling every employer to sort of flexibly identify risks where they are creating and to manage them effectively as they occur. So lastly, it shifted the responsibility of writing legislation away from MPs in Whitehall who do not work at these places day to day, and onto employers who understand the changing risks of the workplace. So this led to new duties for employers to consult employees of those risks and for unions to have a seat on HSE boards. So whilst at the same time, many industrial leaders recognized the business case for not killing your workers, which was nice. So the Act established a framework for workplace health and safety, advocated for a more risk-based and a less prescriptive approach to workplace safety, emphasizing employer responsibility. And across all sectors of work, it required employers to safeguard members of the public, as well as contractors, patients, customers, visitors, and students that would interact with that workplace. So ironically, the committee identified apathy as the most important reason for accidents, requiring employers to pay more attention to employees and attitudes. Very similar to the events that led to Aberfan and the fire in Glasgow. So the number of UK deaths and injuries at work has significantly decreased since 1974, where there were 651 workplace deaths in 1974 prior to the Act. In 2023, that figure was 135, so representing an 85% drop. Whilst employment in the UK has significantly increased. There are some complications to that comparison, especially over those 50 years. The workplace has changed significantly. It can't all be attributed to workplace safety. In the UK, there's been a huge drop in manufacturing, as well as more people are in safer office jobs. But the HSE has had global impact, and many countries and industries use their models for health and safety as their own health and safety frameworks. So let's look at the risks of tip failures globally today. So whilst the UK has some good checks and balances, good monitoring systems, good regulations that underpin the safety of these mining tips, there are countries that either don't have regulation altogether or regulation isn't followed. So, for example, in February 2023, Alxa left Banner, China's northern Inner Mongolia region. A landslide occurred at an open coal mine pit. It killed 53 people and injured a further 6. These were all miners. And miners were buried under debris half a kilometre wide and 80 metres high. Over 900 rescue workers, heavy machinery, drones, thermal imaging, and vital sign detectors were deployed and in the rescue efforts. But a second landslide that evening thwarted efforts due to safety concerns. So by the next day, only 6 survivors were rescued. Investigations since found that the incident was due to illegal construction and production at the coal mine, which was operated by Xinjiang Coal Mine Company. The report also attributed reckless operations of the contracting construction company, falsification activities of the intermediary agencies, lax supervision by relative departments, and loss of management and oversight by local party committees and government. So huge failure across all departments. 19 company employees were investigated, 13 were arrested and currently facing trial, whilst 42 government officials faced disciplinary actions for their negligence. The coal is a major source of energy in China, but its mines remain some of the deadliest, with poor enforcement of safety standards. Despite these regulations being in place, they really need to be enforced. And government have had repeated orders for improvements of safeties. So this incident highlights the importance of not just laws, but compliance of such laws. So 57 years on from Aberfan, the small silver lining is that this event saw some accountability, with 13 individuals arrested on charges of major accidental responsibility. However, it's likely that these trials are ongoing and there's no more information that I could find on their sentencing. I also found some figures of that workers' families did receive insurance payouts, but one value I found was about £1,000, which is obviously nothing with those families. So in addition to the physical dangers such as landslides, subsidence and flooding, mining waste can have a significant impact on the environment and local communities. Mining waste contains toxic materials such as arsenic, mercury and lead, and these can leach, which means that the materials dissolve from rain or groundwater and are carried into waterways, which can ultimately reach drinking water supplies. So leaching is a problem across the world. So in areas where mining is mismanaged or purposefully dumped for convenience, usually in remote areas, maybe with indigenous communities who don't have the resources to complain or to make their grievances public. So I plan to explore this topic in a later episode. I want to look at the 1984 tailings dam collapse in OKTD gold mine in Papua New Guinea. So this is where 90 million tons of toxic mine waste was discharged annually into the river. And I'll cover the David versus Goliath litigation that follows and the impact today. But let's look at mining industry as a whole. So before moving into solutions, it's helpful to understand the chokehold that mining and extractive industries have on our society. Some of the worst environmental and social disasters come from the mining industry, but it's a $2.1 trillion and growing industry. We use mine materials every day. The lithium, which is powering my phone right now, and the gold in my laptop was once underground for millions of years. This needs to be found during exploration stages, dug up, refined, distributed, sold, and we can't say no to mining. It ensures the employment of millions of people and has created towns and economies and enabled people to escape poverty. Mining continues to be extremely energy intensive. It's also land intensive, water intensive, and requires the clearing of natural habitats and sometimes the clearing of people for roads and railways to move the heavy machinery, as well as the mine materials. You could even go as far as to say that mining is responsible for climate change, being the source of all fossil fuels. Improper mining can also have significant social issues. Mining communities can be set up and dropped when they become unproductive, leaving newly formed communities with significant unemployment and gutting local economies. So while the pollution and the use of natural resources can deprive native communities of these resources, they can also poison water supplies and air, causing birth defects and cancer. And in a final horrible feedback loop of destruction, climate change, which has been caused by mining, will likely increase the risk of mining tip landslides and flooding. With changing weather conditions due to climate change, more rain or more extreme storms can disturb previously stable mining tips, while toxic materials can more easily flood and leak into the environment or drinking water supplies. But mining is vital to the production of goods, services, and infrastructure. And I can say without a doubt that everyone listening is touching a mined material. Stopping mining altogether is not the solution, unless it's reducing our reliance on fossil fuels and investing in renewable energy. But we also need mined materials to build a low carbon economy. So to build batteries for EVs, wind turbines, solar panels, etc. So for example, you need 300 to 540 tons of steel to build a 3 megawatt wind turbine, which can power 1,500 households. While each electric vehicle needs around 60 kilograms of lithium for its batteries. In total, it's estimated that an additional 3 billion tons of steel, copper, aluminium, and critical materials like lithium, cobalt, and rare earth metals are needed to build the low carbon economy and ultimately replace climate change causing fossil fuels. So unless we scrap capitalism or become a total circular economy, we need to mine more materials. So in addition to tighter regulation and standards to improve safety, we can also utilize technology to ensure law enforcement and track materials to prevent poor practice, whilst pressuring manufacturers to acquire sustainable and ethically produced materials. Some of those technologies look like product passports. So you could order a ton of lithium and you can require a product passport. So it shows you where that lithium is from, how it was refined, where it was mined, an estimation of CO2 that it took to mine that lithium, for example. So there's some great technologies that manufacturers and even individuals can have access to be able to work out where the materials that they're buying is from and to pressure via their purchasing power the sustainability of those materials. So focusing on the specific challenge that faced Aberfan, the risk of mining waste landslides, we can now monitor mines to prevent accidents, as well as reduce waste being produced in the first place. So, monitoring. Today, we've got really good science to understand what makes mining waste pits safe, where it should be sited, how it should be built, and how it should be monitored and maintained. But how exactly do we know if these are dangerous, and how can these methods be improved? So traditional methods to monitor these pits include physically checking for cracks, erosion, or leaks by visiting sites, physically measuring any slope movement, tracking any vertical subsidence, so has the ground dropped, with things like these things called settlement plates. These plates are installed at the start of a mining tip with mining waste piled on top. If the ground moves, they can detect a change in elevation. The other method is to collect direct sampling of water for its composition to assess leaking. So these methods have been effective and would give early and clear warning signs in the case of Aberfan. However, these methods have some flaws, which means they may not be that accurate, trusted, convenient, or may cost too much to utilize in the first place. So this is where advanced monitoring and sensing technologies can really make the difference. So remote sensing innovation includes utilizing satellites or planes or even drones to capture data remotely. Some have developed highly accurate sensors that can sort of see underground, such as synthetic aperture radar or SAR. This uses active radar, which can penetrate through clouds, unlike normal cameras. These can then provide a broad and often global coverage of areas, whilst the other alternative is to use distributed direct sensors embedded into the waste pits to collect data. This provides sort of a more focused, more precise data points. And some even combine the two. So having a broad overview with the satellite and then specific areas can be directly monitored with direct sensing. So the other side of the technology stack is the software capabilities. So these have the ability to take these data points and make them meaningful. So for example, converting the data points into a map, which identifies subsidence, can identify cracks, or other worrying warning signs like fluidity, for example. The software can quickly compare the current condition of the waste pits with historic data, providing quick comparisons. Many are also using AI to really expedite this process and teach the program to look for typical warning signs based on a typical profile of this particular mining waste. It can take examples of a mining tip in Chile with similar materials, with similar weather patterns, and compare that to a bunch of mining tips with very similar materials in, say, Germany, and compare those two and assess for warning signs there. So why are they better than the recording methods used before? So you don't need hordes of expensive experts with specific training who really need to be on site. The timescales are shorter, so readings can be taken instantly or over a few days, while alerts can be sent to the right people in an instant. These both reduce costs, so make monitoring of these pits more accessible to more people, more accurate and regular readings to see danger signs, and it can be operated remotely, enabling either access to remote areas that might be dangerous or access to parties to assess dangers from afar, which then enables greater accountability. So a company doing exactly this is called Swift Geospatial, based in South Africa. So they use satellites to capture optical imagery, like a high-resolution version of your camera phone. They also use SAR radar, the radar which penetrates clouds, and they have sensors to assess multispectral bands. So these are sensors to detect wavelengths that we can't see. This enables the monitoring of surface water changes. They then pair that with their AI software, and that can easily track shifts in waste pits, comparing today against historic data. Whilst they also boast having a easy-to-use interface that enables untrained people to use the program to produce interactive maps, charts, and illustrate changes in a time series to really better communicate any issues at site. So imagine you are a site manager, you've employed Swift Geospatial to run all of this tests and analysis, and you need to prove to your local governor that there's one site that needs funding or remediation because it's dangerous. You can really, really quickly produce a map and highlight those danger factors and communicate it in a really visual, clear way to the people that are decision makers, to ensure swift action and quick disaster prevention. So in March 2021, Swift Geospatial deployed its system with gold producer Nordgold at its Lifa mine in Guinea. The aim was to proactively identify potential risks at its tailing storage facility. And reflecting on the partnership, the director of ESG at Northgold said, "The latest satellite technology enables cost-effective monitoring of this expanse with regular updates. Using this rich data, our aim is to continue reducing our impact on the natural environment and ensuring the sustainable development of local communities." Another approach is using direct sensing. So companies like Muon Vision, based in the US and Chile, they bury their sensors underground. This then picks up natural X-rays, which are cosmic rays called muons. These are always traveling through the sky, through the earth, and as these travel through pits of mining waste, the sensors can detect them. And based on the difference of how these muons move through different materials, the sensor and the software can build a 3D map of what's going on underground, including its stability. If there are any internal gaps, if there is any liquid moving through the site, this piece of kit can pick it up. It enables a sort of near real-time underground monitoring solution. While this technology is yet to be tested in a real-world situation, it shows really high promise in its ability to highlight problems with a high degree of accuracy, enabling targeted safeguarding. Another solution you can employ is to prevent a tailings pileup from needing to be constructed in the first place, so reducing waste. And you can do this with something called surgical mining. It's a really another cool solution where innovative surgical and precision drills are employed instead of these big clunky things that need all the waste to be piled up alongside. So one such company is Novomira. They're based in Canada. They are a startup creating these surgical and sensor-enabled drills, as well as a software operating system. The two work together. The tool is used to scan and map underground via very, very small boreholes to determine exactly where the material is. The system then calculates an ultra-precise journey for that drill to access the material. So it uses AI as well to identify an area where the material is most likely to be, so it reduces many of these boreholes having to be drilled. The drill can then extract materials whilst it backfills the hole that would have been waste, thus undertaking real-time remediation and eliminating the need entirely for these huge, dangerous, polluting, unstable waste pits. These technologies are in early stages, but show great promise to mitigate or prevent problems with mining waste before they happen. If these are scaled to their full potential and used in tandem with solid regulations, the apocalyptic events which fell upon Aberfan, Alxa, Lefbanna, and many, many more sites can be prevented. So finally, I want to revisit the Aberfan of today. So Jeff, the little boy with the white hair who was rescued from the rubble, he moved away from Aberfan. He received a degree at the University of London in the 70s and became an accountant. In 1989, the Aberfan coal mine closed and the area fell into disrepair. Huge generational and shared trauma remained within the community, and the Aberfan of the late 80s, early 90s had very high unemployment, with many struggling with their mental health. Jeff felt compelled to return. He said, "The decision to come back to Aberfan was solely based on addressing the social and economic issues within the community, because we were facing another generation who effectively would be written off. And when you look at the people who died in the disaster, they could have been bank managers, general practitioners, engineers, ambulance drivers, and they never had the opportunity to do that. I didn't want to see another generation of young people written off." Jeff utilized his accountancy skills and set up the Aberfan and Merthyr Vale Youth and Community Project, which helped hundreds of people get their life on track. Engaging young people into auto mechanics, getting the community a fleet of cars they could get 2 jobs, was also setting up parenting and toddler classes. But Aberfan is not a story of what went wrong. It's also a story of resilience. The people of Aberfan rebuilt their village and preserved the memory of their children and demanded that no one, no institution, should be allowed to forget. Their dignity in the face of loss changed how the UK handles industrial public safety, public grief, and even royal responsibility. So as we remember Aberfan today, we're reminded that disasters are rarely accidents. They are often the final link in a long chain of avoidable decisions, and the true measure of a society isn't just how it mourns, it's how it learns, changes, and honours the voices it once ignored. In the next episode, I'll be looking at the Great Pacific Garbage Patch, the 1.6 million square meters of trash and plastic discovered in the North Pacific Ocean in 1997 between Hawaii and California. I'd love to hear your thoughts, whether it's feedback on the episode, question you'd like answered, my awful pronunciation of Welsh villages and towns, or personal experiences connected to the topic. Have you or your community lived through what you would consider an environmental disaster? And what does prevention mean to you? So you can reach out on Instagram at Apocalypse Nope, or by leaving a comment wherever you're listening. I'll leave some links in the show notes, as well as all the sources that I have used for these 2 episodes. So don't forget to subscribe, share, leave a review. It really helps people find the show and join the conversation. I'm Holly Stower. This is Apocalypse No. And remember, stopping the apocalypse starts with understanding where it began.